Good morning, ladies and gentlemen. Welcome to the EUROCONTROL Air Transport Innovation Network webinar. My name is Peter Charoba, and I will be the moderator during the session today. We will be looking at the user-driven innovation. Today, we will look into the projects from our innovation portfolio. There will be from the cycle one of our portfolio for those projects who made it from the minimum viable products to the operational trials. I will guide you through this section of the webinar. Then we will look into the cycle two, which is the ongoing part of the portfolio where we have 8 projects, and we will have a look at 3 projects that are currently in the build phase, and we will see some preliminary results, still moderated by me. Then I will hand over to my colleague Marta Lopez, who will introduce the new cycle 3 batch of the projects, where we will introduce the projects with new military stakeholders and the airports. And we will have to, at the end, the concluding remarks and the next steps to be presented by Laurent Renou. Now, today we will talk about the user-driven innovation in our portfolio, but before we do so, I would like to take the opportunity and on behalf of Laurent Renou, the head of EUROCONTROL Innovation Hub and head of the Air Transport Innovation in EUROCONTROL, to welcome you. He couldn't join us at the beginning of this webinar. He will be with us towards the end of the webinar, but I wanted to take this opportunity to talk a little bit about the rebranding of our center. Many of you know that EUROCONTROL Bretigny has been known for years as EUROCONTROL Experimental Center. There has been a rebranding communication campaign in mid-September where the center has been renamed from EUROCONTROL Experimental Center to EUROCONTROL Innovation Hub. Now, this is in support of our new updated strategy. And just to make sure that although the topic of today's webinar will be our innovation portfolio, the Innovation Hub as a center now does not do only this part of projects or this group of projects. We also have 3 other large work areas where we do all our contribution to the CSAR work program. We are working with our stakeholders from EUROCONTROL member states on the large scale, the real-time simulations and fast-time simulations. And we also have a large portfolio of the projects in the area of the drones. Now, of course, today we will zoom in on the particular portfolio of the user-driven innovation. And of course, many of you may now ask, because you have joined the event, our Promote event on Innovation Hub back in April this year, we just called Innovation Hub Promote event. What is the difference? And of course, might be a bit of confusion. So that's why I would like to take some time now to explain that yes, the Innovation Hub is now the new name of the center. And because of this name change, we had to slightly update the name of the initiative itself. Now, the initiative itself, we decided to call it Air Transport Innovation Network. That's why the webinar, Air Transport Innovation Network webinar. Now, why network? Network because we are putting together the key operational users, ANSPs, airports, airspace users, military aircraft operators, to bring them together so that they can pitch to us their operational challenges, and we can try to put together the projects and develop digital solutions and services to respond to these challenges. How we do that, we try to combine our expertise with an agile approach. And of course, the key objective here is to try to accelerate the market uptake, streamline from innovation to deployment, and targeting primarily short-term operational improvements. So here, of course, in the world of innovation, we call it more incremental innovation. So we are not going after the revolutionary or disruptive type of innovative ideas. This is, of course, complementing the CSAR program that we are heavily involved in. Now, of course, this is a network. We cannot do that alone. So we have to do that through partnerships with the operational stakeholders. I already mentioned them, ANSPs, airports, airspace users, but we also do collaborate with research centers, universities, and industry, which is very important, especially in the phase of the handover when we'll be talking about the deployment of these solutions. Now, zooming a little bit more at the portfolio of this innovation-driven or the user-driven innovation, we in EUROCONTROL distinguish the 2 types of operational stakeholders, external and internal. The objective of today's webinar will be to focus on that external part, where we have the Air Transport Innovation Network. And there we will be on the agenda talking you through the projects in our cycle 1, Fade and Curfew, cycle 2, which is a long list that is there, but we will not go through that now. And we will have a launch of the 3 new projects in the cycle 3. Just a quick word on the internal operational stakeholders. In the EUROCONTROL Innovation Hub in Bretigny, we collaborate with our internal colleagues in EUROCONTROL with Network Manager in Brussels, where we have 3 projects currently together in a collaboration with NM Lab on the Predict AI, on the network manager dashboard and optimization of the regulation scheme. We also collaborate with our MUAC InnoLab colleagues from Maastricht Upper Area Control Center, where we are scoping right now the project called Green en route separation, and we have concluded recently 2 other projects last year that were AI-driven applications. Now, as I mentioned today, we will be focusing on this external part, and we will be looking at the cycle 1, cycle 2, and cycle 3. But before we get into that, I would like to quickly remind the process that we are using in this innovation portfolio. Our innovation process is composed of the 3 main elements, and there is connect, build, and promote. Connect, I already spoke about a little bit, where we are really trying to make the network and connect with operational stakeholders. We are organizing ideation pitch sessions where the stakeholders come, we bring the other stakeholders there, let them discuss. They will prioritize the subjects, and then the group of experts from EUROCONTROL will help to choose and make the feasibility assessment of the ideas before we decide to launch particular projects. Once we launch them, we enter into the so-called build phase, where in the build phase, the objective is to address the user needs and these challenges, to develop the proof of concept, prototype up to the minimum viable product. If possible, do the trials where we can really demonstrate that the users can get benefits and we can respond to this operational challenge. Once this is done, the next and very important phase is the promote phase and the handover. So it's basically a decision on the go, no go. Does this work or do we fail? Which is fine to fail, because we can fail fast to improve later on in terms of these projects and their success, and whether they can be handed over to industry for accelerating the deployment or not. The promote phase is also this type of webinars. We do public webinars. We will do technical webinars where we can zoom in a bit more in the detail, where we can share the results with all of you. Moving on to the next one, which will introduce how we started this initiative back in September 2020. We started small. We wanted to learn by experience, and we wanted to grow gradually. So the first group of operational stakeholders was the airlines, that are listed here on the slide. They proposed to us 12 projects. And from the 12 projects, after the prioritization, we have decided to launch 3. And 2 of these projects have made it from the minimum viable products that have been developed in the 6-month cycle from September, October 2020 to March and April 2021. They made it to the operational trials. And I'm very pleased that now I can introduce the next session, where we will welcome the first speakers from combining the operational world and the EUROCONTROL experts. So the next speaker who will talk about the operational trial of the project called Forecast of ATFM Delay Evolution is Jorge Franco from vueling, and he will be joined by Brice Genestier. So Jorge, over to you.
Hi, good morning. Hola, from Barcelona, from Vueling Airlines. So I'm going to introduce you about this project. It's called FATE, Forecast of ATFM Delay Evolution. Some people from EUROCONTROL have participated. They are the key of this project. There are some Ramon Dalmau Codina, Camille Anogo, Brice Genestier, Dagen Smith, Peter Choroba, and the presenters, of course, I'm Jorge Joaquin Franco Bustos from Vueling, and the second one is going to be Brice Genestier. All right, so this project was so interesting for the airlines because we were demanding a solution about regulation, especially, and EUROCONTROL has chosen this project, and the airlines also has both for them. One of the main reasons that we need this kind of tool, it was about the uncertainty concerning the CTOLs, which affects economic performance, operational performance, and passenger experience. So the main idea about this is the airlines doesn't know how it's going to evolve this regulation. They don't know if it's going to improve, it's going to maintain, and it's going to get worse. So the project scope was developed with 5 participant airlines. Vueling Airlines was included. And the main thing is to introduce the artificial intelligence-driven delay prediction tool to inform about to flight dispatchers. OCC is going to be involved, of course, about the FTM delay is going to increase or decrease for a regulated flight as technical phase. That's so important for OCC. for to manage and especially inform the crew, airports, holdings. So all the actors are going to be involved, how is going to be the regulation in the future. So the idea is to get the trend of the regulation. So what were the expected benefits for airlines? So, of course, efficient fleet and resource management, as explained before, gates, especially for airports, how they are going to be managed, crew, cabin crew and flight crew are going to be informed, and they are going to embark the flight when they thought that the regulation is going to evolve, of course. Better delay management and improve passenger experience, that is so important in this time.
Thank you, Jorge. Good morning, everyone, from the EUROCONTROL Innovation Hub in Brittany. We started to develop in December 2025 different machine learning models. The airlines chose 3 of them. The first indicators is a trend that the CASA delay will increase, decrease, or remain stable. The second indicator is a probability that the CASA delay will decrease to 0 in percentage. And the third indicator is the predicted ATFM delay at takeoff time in minutes. We integrated the 3 indicators on the EUROCONTROL network prototyping platform. This is a kind of CHMI-like tool. In March 2021, we started to validate with the 5 airspace users the fade indicators. In replay mode, we were able to compare the delay prediction indicators, the fade indicators, with the CASA delay on 3 different days from 2019. One day was a normal day with high delays. Another one was a summer day with multiple thunderstorms in Europe. And the last day was a day with multiple strikes in Europe. The delay prediction error was reduced up to 63% for messages, flight messages received at least 2 hours before COBT, 2 hours before SIT1. For the normal day, the fade indicators performs well with good prediction and good stability. For the day with strikes, the predictions were good as well, but sometimes with low stability. For the day with thunderstorms, the predictions were not so good and not so stable. This is an axis of improvement. We probably need to increase this specific situation, the weight of this specific situation in the training of our model. The airlines, we received a positive feedback from the airlines on the new indicators and the HMI. They all wished to continue to test the tool and to measure the impact on their operating methods to gain trust and experience for their decision-making process. Next slide, please. Okay, this is the work we have done during the summer 2021. We have added the live trial mode. Now the fed prototype is connected to the NMOps system via B2B connection. We receive live NMOps data. The AI model can now be interrogated on actual flights. The tool is still a mock-up, a prototype. As of October 2021, the flight dispatcher is able to use the tool in their airline's OCC. Thank you, Jorge, for the nice pictures of the vueling OCC on the right. We recognize the tool on the left screen. To monitor the performance of the tool, we have added performance reports generated on a monthly and weekly basis. These reports are directly accessible via the fade interface. You have an example on the left. The blue color is for the fade data. The orange color is for the CASA data. The horizontal bars are the proportion of regulated flight for each airline during the month of October. The vertical lines are the performance indicators. These are the delay prediction error in minutes for each airline in average during the month of October. We can see a similar trend of improvement as we have seen during the trial in March 2021. In parallel, we gather the EU feedback on regular meetings every 2 weeks to get the ideas on the improvement for the algorithm, for the HMI and the performance indicators. I give the floor to Jorge for the last part of the presentation for him to give you his view and to share with you the EU feedback.
Thank you, Brice. So we're back. I'm going to share with you about the airline users' feedback. So some interesting cases despite low regulated traffic. All right. So the feedback was quite positive, talking about operational and encouraging the pursuing in this direction. All right. So Transavia France has explained high CASA delays, has action taken to inform passengers at the right moment was successful. So that's quite important about to inform the passengers about their regulation is going to be. So they know perfectly about how it's going to improve. That's the idea of the project. About Air France, we have some experience with them. Also, the quote was flight with 9 minutes delay subject to rerouting. So predicted delay of 0 minutes suggested to wait and see. In the end, the flight got 0 minutes delay. So that's quite important about to know previously if the flight dispatchers has to reroute or not a flight about the trend that the fate has shown. All right, so from vueling we have 2 quotes, quite interesting. With fate, we will be able to optimize resources and reduce standby crew activation. That's so important for us. So we can know exactly if we're going to need the standby or not. All right. And the second sentence or quote was advance to the crew the trend for the regulation and plan when to start and be ready for embarking. That's so important for us because the flight crew used to contact about if the regulation is going to improve or not, because they are going to embark before or after, depends of the news or the information we provide to them. So the next steps are fate prototype for summer 2022. That's going to be really helpful, especially for the summer that is coming. And also is developing the B2B mock-up services for airlines. Also, it's going to be really important because you could introduce this information in your own systems. And that's all from my side. Thank you.
Okay, thank you very much, Jorge from vueling, and of course also Brice from EUROCONTROL for this brief update on the current operational trial. It is really, we are very glad to see that this project made it to the operational trials and is already providing benefits to the airlines, although still in the trial mode. Of course, there was a bit of challenge for the project because as the project has been undertaken under the heavy COVID circumstances, where we had no traffic and the replay was the only used in the initial trials, the project team had to see whether now with the traffic that is picking up back to 70–80% of the traffic, whether the algorithm can still provide a good performance. We are very glad to see that this is the case. So that's perfect. We will see, and we are looking forward to see the trial next summer with more airlines potentially participating there. So thank you again for that. Let me introduce now the second project from this first cycle, where we are moving into the operational trials. This second project is called Curfew Collaborative Management, and I'm glad to introduce the next 3 speakers, who will be 2 speakers from the airlines from operational stakeholders, Lucas Weber from Swiss International Airlines, who will be joined by Estelle Bandavong from Transavia, and of course by also the Giuseppe Murgese for representing EUROCONTROL as a project leader. So over to you.
Thank you, Peter. Good morning, everybody. This project basically started 1.5 years ago, more or less. And it was, as Peter said, in the period of the COVID crisis, so it was quite difficult but to run it. But at the end of the day, you will see the results, the achievement were very, very important and actually worth to continue on the development on the trial phase. The curfew subject has been requested by a couple of airports in the famous pitching session, Zurich Airport and the Airport de Paris, Orly, plus the airlines. You've seen the logos in the previous slides there, because I would say for quite obvious reasons, the possibility of predicting a potential curfew infringement quite in advance, well in advance, in order to act or react in terms of operations and of course in terms of cost savings. And that's why the idea was to try to introduce or to use a quite different methodology to address this problem by using the artificial intelligence and making use, of course, of a huge amount of data that EUROCONTROL have in their databases. So the approach to the project was the following one, as you can see on the slide. Airspace users plus the airport basically provided us with a collection of information of requirements, which were the current versus the target ops or post ops. So the tool in their perspective would be used or could be used in operations or as post ops. This was not clear at the beginning. Then we used 2019 as a reference year in terms of data from NM databases for the schedules and the tactical information in order to build basically the model and of course training the model. You can see on the right side of the slide a representation of it. Then when it came to the validation and the test plan, we of course used a different set of data in order to understand a little bit and to see and assess the performance of the model in that sense. So here we are talking about 2019 as a reference, 2018 as proposed by our customers, by our partners in the project, and also 2020, because the 2020 traffic situation was very special, very different from the usual one. And of course, it was important for us to understand a little bit the behavior of the model. The reference in terms of, I would say, operational situations or events was using data concerning a high number of diverted or canceled flights and a high number of ATFM delays. So it was a sort of stress for the model to see the performance of it. And as you can see, then on the last bullet of the slide, the results were quite interesting in terms of, I would say, support to the users, to the partners. An average of between 11 and 35% of improvement with respect to the current operations. Of course, less improvement on 2020 traffic, but now we do expect a different behavior in the future. And then, of course, based on this, when the project was completed, we produced a report, a full report. It's sort of living document because we are completing or we are still feeding the document with the outcome of what's going on today. And today, what we are doing is the integration within the Mirror Flight Watch panel. Mirror is a tool, but we'll see this in the next slide. And then the integration within the NM system. Thank you, Peter. Mirror is a tool that has been developed by EUROCONTROL, and the Mirror team actually participated very actively to the development of this. Thank you very much for their support, for what they did. Developed basically to do what? To build a sequence of flights for a given aircraft, and of course give the opportunity to the users, to the final users, to detect or to predict delays in principle, and of course act on those. As you can see there, this is the HMI of the of Mirror, and this is the specific case where basically the Curfew model, based on the schedule information and of course the TACT information which come from the airlines and from the NM database, is able to then predict or potentially run and predict whether a flight will or may infringe a curfew or not. Okay, this interface now has been made available to the users since last May in 2021, and of course we will be waiting for their feedback from next year. I would say beginning of next year. But we did the same also for the airspace users, because for Mirror it was airport, and now we move to airspace users. And in this case, of course, I introduce Lucas. Give the floor to Lucas Weber for explaining what they are doing in Swiss with the tool.
Yes, thank you very much, Giuseppe. On the slide, you can see the HMI that we've been using to test and validate the calculations of the model. On the slide, you can see the results from that for the rotations, the aircraft rotations, where the model predicts possible infringement on the curfew. This HMI is connected directly to the NM Lab API. which we also have access to directly, and that we also can use to submit schedule data for our flights that is then used in the calculations. And past few weeks and months, we've been testing and validating the information that is shown there by comparing it to our actual operational systems and our own operational data to see that data is correct and useful, and that we can give feedback based on that. Of course, for that it was very important for us to have the actual operational data fed into the system from NM side. Going forward, we plan to connect our systems directly to the API, so that we can also use the results there as a valuable input for any predictions and alerting of our ops controllers, profiting also from the very large data set that has gone into the model, using it as an additional source of information, which will then in the end lead to hopefully mitigate curfew infringements and recognizing critical rotations earlier. In the future, we hope that we can keep the momentum of the project going and implement it in the NMOps system, and also being able to access information through the existing B2B services as soon as possible, because that will be very valuable for us as an airline. Now, I also want to take the opportunity to thank the collaborative curfew management team, so Giuseppe, Benjamin, Ramon, for their support and the commitment to the project during the last months, also for the very quick implementation and reaction to feedback. That was very much appreciated. And now I want to move on and give the word to Estelle from Transavia.
Hello everyone, I'm Estelle Van der Brong and I'm working at Transavia France as a dispatch manager. So here in this slide, you can see that the user interface, the NM lab developed during this project, it's really easy to access, and it allows airlines which don't have API integration with NM to highlight flights close or potentially impacted by curfew infringement in a quick and simple view. Rotation of the airline in the gun display are automatically updated according to known delay or turnaround times. And also this HMI is only showing rotation where an overview is required. So it's really more easy to read because in green there is a flight of the airline, and in red there is a curfew time window for the rated airports. And so when both are overlapping, the situation awareness is required by the user of the airline, and decision-making can begin. So this tool might also allow airport and NSPs to have an overview of the leg with a high priority due to curfew by location. It's a help along the day for NSPs, which may receive late delays on our rotation by airlines. So for now, we are the premises of our tests. But of course, we're going to continue using this tool as long as we can, and at least until the end of 2021. Indeed, the Christmas traffic will allow us to get more feedback from the user on the tool and to communicate with NM Lab to continue to improve prediction on possible curfew infringements. So thanks a lot to NM Lab team. Thank you.
Thank you, Estelle. Peter, if I may, a very last word is on the fact that basically now we have the opportunity for airports via Mirror and for airlines via the API. Very welcome then to representatives of airlines who may be interested to, of course, use the tool and try to integrate them in their operations. So do not hesitate to contact Peter or to contact myself. And of course, we will be very glad to make this available to you as well. Thank you, Peter.
Thank you very much, Giuseppe, Estelle, and Lucas for this presentation of the second project from the portfolio in the cycle one, where we are moving from the MVPs to operational trials. We are really glad to see this, that the operational trials are ongoing. And of course, this is the first batch of the projects where we have entered effectively already what we call the handover phase, where we are working closely with our colleagues from Network Manager, because they should be the one basically deploying these two solutions to make them available after the successful trials, operational trials, to the users. And we expand the usage, of course, where more airlines and airports can get the benefits using these tools. So thank you very much for that. Now we will move on to the next phase or to the next cycle. And as we were speaking about infringement and delays and reactionary delay, I've noticed that, of course, we have a minor delay in the webinar itself, 5 minutes. Let's see if we have built in enough buffer that we sometimes do in the schedules as well, whether we can catch this up. But in the cycle 2, we will have a look how this whole cycle 2 evolved. Those of you who attended the April webinar earlier this year, we have presented that, of course, after the first cycle where we worked only with the airlines in terms of ideation, in this cycle, we have introduced and invited also ANSPs and airports. So there is a long list on the slide. Now, altogether, they've presented and pitched through these sessions 16 ideas, out of which there has been a prioritization exercise depending on the stakeholder group, airports, airspace users, ANSPs. And then there was a feasibility assessment, and there were 8 challenges that have been selected to enter the build phase. Now, these are the projects that have been selected. The 8 projects, we have 3 in the airport group, 2 in the airspace user group, and 3 in the ANSP group. What you see highlighted in green are the projects that we have selected to give you a quick update on their current status, because all of these 8 projects are currently ongoing, and they will last until early next year, when you will get the final output of these projects, hopefully presented during the next event that will take place in April next year. So let us now move on and have a look in particular at this very topical on delay visualization, as we have a little delay in the webinar as well. And I'm glad to introduce now the next 2 speakers from ENAIRE. We will have an FMP Francisco Tortosa, and we get from EUROCONTROL from the airport team, from network manager, we get Francisco Salguero. So the floor is yours, Francisco.
Hi, good morning. Can you hear me?
Yes.
Okay, thank you very much, Peter. Well, this, as Peter mentioned before, I mean, this local delay visualization project was proposed by AENA and ENAIRE. It was a proposal to expand a little bit the achievements in the net curfew project in the cycle 1, where we demonstrated that the initial assessment or predictions of reactionary delay could have a benefit in terms of operations management, detecting net curfew infringement. The proposal was, so why don't we use these predictions models that we have developed for the net curfew to improve other aspects in operations from the 3 different stakeholders that are participating in this project. From the airport side, we have AENA, which is the Spanish airport operator. From the NSP side, we have ENAIRE, and the airlines that are participating in this project are SAS, Vueling, Ryanair, and Swiss. The objective, as I mentioned before, is why don't we find if there is another operational aspect that we may improve using an assessment or initial assessment of reactionary delay in the future flights. So, what do we understand with reactionary delay, Peter? Do you mind? Well, it has been presented before by our colleagues. This is a representation of mirror. Okay, what we mean about reactionary delay is that we are able to assess when a flight is going to be delayed based basically on the inbound flight. So for our first stakeholders, which are the airports, Peter, airlines, what we wanted to do is to make a specific visualization that would help them to improve the operational decision based on the cost impact of a reactionary delay. We have seen that the most important impact in terms of cost for airlines is the EU 261. And there is a study that was done in collaboration with the University of Westminster, where basically we were able to assess which is the impact of in the cost depending on the aircraft size and type, and the seat configuration, and how many minutes of delay compared to schedule. We are able to put a cost index So with that analysis, sorry, can you go back? With that analysis, together with the predictions that and the models that we built for the ENAIRE Curfew project, then we have developed a new HMI that is the sorry, Peter. There is this one, where basically for one specific airline, we are able to show what are the flights that are going to be heavily impacted, so the cost index is very high. So airlines can manage by exception and to decide whether they need to apply or to do some actions on some specific flights to reduce the impact, the cost impact these flights may have on their operations and their economic performance. This is for the airlines. For the next stakeholders, the airports. Well, the objectives for the airports are basically to improve the airport stakeholders' tactical planning, basically for the ground handling and the airport operator resources. Obviously to improve passenger experience, and for them it's very important also to have an early detection of conflicts. If they are going to have some apron issues or parking issues, it is important for them to start detecting those things as early as possible. For this specific stakeholder, we have agreed with them to produce an HMI that basically represents two different views. One view is the plan view, where we are representing what is the demand in a specific 15 minutes time frames. Each dot means a flight. And then we can also produce a tactical view, where basically we are using the same predictions that we have used in the other models to show to the airport what are the flights that are arriving ahead of a schedule, are arriving on time, are arriving a little bit late, or are arriving very late. So they can detect when there is a potential of a delivery in some cases, and then they can also see if there is a different pattern in their own, or they are expecting a different pattern in the traffic arrivals, so they can't update or make some decisions, operational decisions, to improve the performance and the passenger experience. And the last stakeholders, the NSP, I give the floor to Fran, that will explain better what are the objectives from them.
Okay, hello, good morning, everyone. Okay, first of all, for us as ANSP, from the FMP point of view, the problem we have is that we basically work on the demand data prediction that is provided by EUROCONTROL, and with that we have to take decisions, and these decisions affect many flights, airlines, and passengers. So of course what we want is to have the best possible demand prediction. But currently the data provided by EUROCONTROL does not include the effect of this knock-on delay. This is not currently taken into account. So we're working on data that is not fully correct, as you can imagine. So it's so that's why we are very interested in this project. So for us, the objective, as mentioning here, is first to analyze the impact of the knock-on delay on the NSP network to see which are the sectors that are more affected by this effect. This will help us improve the traffic prediction for those sectors affected, to be able to have a better data to take better decisions, as I mentioned. For that, we need to have a visualization that is comparable or similar to with the current FMP tools, so that we are visualizing the demand prediction per traffic volume, and like CHMI currently or some other tools. Then it's important also for us that to have an assessment of by how much are we improving the prediction with these models that we are using. And if the results is what we expect, which is to have an improvement, then we would like to promote the integration of this information into the ETFMS traffic demand data, so that we are working with this better data for our decisions. Because yes, above all, what we want is to avoid regulating smoke, which is that's the way we call when we are regulating demand that is not actually there, because there's been some effects, some delays that make that we are seeing some bar of demand that is not really true. So that's what we want to avoid, because we are affecting traffic that and that may not be necessary. So for that, Peter, if you can pass to the next one, where we have a view of the current prototype that is in development. Here you can see in the top left, there's the network view, which will be the starting point for the tool, where we can see the impact of the knock-on delay on our network, on the current sectors. So depending on the color, we can see, okay, which sectors are most affected by this effect. Then by clicking on one particular sector, we can see in the top right, the bar chart. That's the typical bar chart used by FMPs in blue. And then on top, we can see the demand that is modified by the effect of the knock-on delay. That would be, let's say, a better prediction of the real demand. So in this case, for example, you can see that the peak remains similar, but then there's a second peak of demand that is not gonna be the same. And then we can also go into the details of the flight list, where we can detect patterns, so see the airlines that are most affected, or these kind of things. So this is the project as it is right now. This is basically comes to the conclusion of our presentation. The development will continue until early next year, and the final results will be presented, of course. And we expect to perform some operational testing from the point of view of all three stakeholders involved, from ENAIRE, from SAS, from airlines, and also from airports, from AENA. And then if the results are promising, we would like to promote the integration of this data into the ATFMS, and also, or otherwise, or in the meantime, to be able to have the data available via API, so we can continue working on it and have it available.
Okay, thank you very much, Fran, and thank you very much, of course, Paco, as well. I think we just heard about a very interesting project that is trying to do a modeling and prediction of this knock-on effect that actually provides a benefit to immediately 3 different stakeholder groups. So we've heard about it, that the airlines, airports, and also NSPs and FMPs would benefit from the outcome of this project, and we are very looking forward, to see that project evolving. And of course, we'll be discussing then the next steps, in the next phase, next year, how we can bring this and accelerate the uptake of this solution later on. So thank you very much again, Fran and Paco. Before we move to the next presentation, I would like to just say something that I have actually forgotten, so I apologize for that. At the beginning of the webinar, I forgot to mention that as we are going through quite heavy agenda and giving you progress update on a couple of projects in our innovation portfolio, we actually do not have the Q&A session. So we don't have time to actually respond to the questions, but for all the attendees who are connected to the webinar, if you have a particular comment to make or a question that you would like to raise, you can still use the chat option that is available in the webinar. We will see if the panelists can try to provide the response in a written form now, if they have the time, especially after their presentation. If not, what we can do, we have your contacts, and if you leave the comment or question there after the webinar, we can get in touch with you. Also, to all the interested parties, or the partners or stakeholders would like to know more about some of these projects. So please do not hesitate to use the chat option. At the end, you will see also the email address through which you can access and contact us where we manage the whole portfolio of these innovation projects. Now, the next speakers, we will have actually only one because there is an apology. Mathieu Gudurand-Gobert from Air France finally couldn't join this webinar. So the next project will be on prediction of runway in use, will be presented by a EUROCONTROL expert, Floris Herma. Floris, the floor is yours.
Thank you, Peter. Good morning, everyone. So yes, as Peter mentioned, data scientist in the airport unit and technical leader of this project. It all started this summer based on an initiative from Mathieu Durand-Gobert from Air France, who unfortunately couldn't join, as well as several airlines, or I must say the end users, which are KLM, Vueling, Ryanair, Swiss, and Transavia. We work closely together with them to develop a digital and agile solution based on their operational challenges. So the project kicked off in October and is progressing so far very well during this first 1.5 months. And this morning I will give you a quick summary of the interest, objectives, the data used so far, and where we are, and the next steps, of course, within this project. So last summer, requirements have been specified based on the needs of those 6 airlines. And the airlines are mainly interested in such a tool because of 2 reasons. First, it helps the dispatcher in planning the flight and give them, for example, the runway in use for the coming 4 hours upfront. And secondly, to support the pilot who is then able to add the arrival departure runway into the flight management system, the FMS, 1 hour to 30 minutes before departure. So the moment actually when the final flight plan is accepted. One of our key objectives is to deliver a user-friendly app in which the arrival and departure runway are both clearly visualized for a single selected airport, as you can see here for Amsterdam, or in a table when multiple airports have been selected, as well as the prediction accuracy for each arrival departure runway. The airlines requested to have this tool ready for all European airports by next year, meaning 4,000 airports in total. A second objective is that the information will be exchanged through SWIM, the system-wide information management, and the NMB2B to harmonize the exchange of weather and flight information for all airspace users and our stakeholders. Next one. Next slide. Yes. So what are the objectives from the airlines? So we know that in Europe, the information for 4,000 airports in a single tool is not available before the aircraft has taken off, which is of course not optimal to calculate the route. However, in these days, in the US, the runway configuration information is provided already by FAA, and users such as Air France, for example, or Air France uses this information already, like dispatchers, to calculate the flight route in the US. So after having the discussions with the airlines, we concluded the following expected benefits when implementing such a tool in Europe. So most airlines are interested in supplementing the expected arrival runway in their flight plan to optimize their fuel calculations, but also increase situational awareness for pilots and the dispatchers about the airport configurations or the runway in use. A shared level of information between the pilot and dispatchers, so better accuracy in runway determination, either by the dispatcher or the pilot during the flight preparation. For example, also for Amsterdam, taxi in and out prediction for optimizing fuel and to better timing when the aircraft arrives. And a final one, we know that the aircraft capacity predictions are needed for 3 things. So the air traffic flow management, airport service operations, scheduling, but also system-wide simulations. And since the capacity of an airport depends on the runway configuration being used, the forecast of the runway is a key step towards predicting the capacity of an airport. Next one, yes. So the data used so far, we know that the runway configuration is the key driver of the airport capacity at any time. So factors like weather, such as wind, visibility, time of the day, but also traffic demand, air traffic control workload, but also the coordination of flows with neighboring airports are influencing the selection of the runway configuration. So for the moment, to predict the runway in use, we make use of 2 different sources. For the first one, we make use of final approach and runway ADS-B data. The project will use Flight Radar 24 data since this offers a global solution for all potential airports. And we basically would like to make the model as generic as possible. For the other one, the weather, we use TEFs. TEFs includes the weather forecast information and are issued at least 4 times a day, every 6 hours for the major airfields. So at night, 6, at 12, and at 6 UTC, and generally applied to a 24-hour period in an area of 5 nautical miles from the center of an airport or region. At a later stage, we will also include the METARs and SIGMETs, but this is something to be included later on. So where are we? We have been able now to connect the data towards the data lake that allows us to extract Flight Radar 24 and weather data. We have a first model working based on Flight Radar 24, actually for the bigger airports. We started with Amsterdam, CDG, Toulouse as well. Now we don't have live weather yet, but this is something we will include in the next month. The method is developed in a way that we are able now to identify automatically the arrival departure runway for each European airport. So, however, when predicting, we would need to retrain it separately for each single airport, since each airport have different patterns, behaviors to learn from. At the moment, we are also looking into making a single machine learning model for a cluster of airports. And the best approach will then be selected based on computational speed, accuracy, and the amount of data used. So you see here an example where we can actually move the slide bar in real then. What we would like to have is this visualization to build up for 4,000 airport. This is an example for Amsterdam Airport where you see the arrivals for runway 36 left, 36 center, and the departures runway 06. You could move the slide bar up to T0, from T0 up to T4. So wherever the pilot or dispatcher is interested in. So as I said, 4,000 airports should be included in this visualization too. And the architecture is built in such a way that we merge, clean, prepare the data in a first step. Then we are adding every day new data in from flight radar 24. And a third one to make the predictions that are updated every 5 minutes. So let's say the map is updated every 5 minutes. Now, another thing that the airlines requested is to also include the accuracy for each arrival and departure runway. So this was the quick overview of the status of this project, Peter, for this first 1.5 months. Back to you.
Thank you very much, Floris, for this presentation. And of course, it is quite impressive to see what can be achieved in 1.5 months. And what I forgot to maybe mention at the introduction of this cycle 2 is that the projects have not all started at the same time. They have been pitched around April time when we announced the projects, and then it took a few months to actually organize the kickoff the projects, to agree on the partnerships who will be contributing to each project. And then of course the summer period didn't help a lot, in terms of speeding up our scoping phases, but most of the projects are now in the build phase, and we have already seen 2 of those, the knock-on delay visualization and prediction of runway news, and how they can quickly and agile way, develop the initial prototypes. And they have challenging objectives, I must say. When I hear Floris, of course, what you're saying, that 4,000 airports and predictions and a lot of requests, I think this is very important, working together with the stakeholders, trying to adapt as we go, and try to adapt also the solution to the needs as they are evolving, because the scope may be changing along the way as we get more information ongoing. So thank you again for this. Let us move on to the third and the final project in this cycle 2, where we will have a look at the project with a very long title that is called Optimization of Airport Resources through Block Time Predictions and Passenger Demand Predictions. This idea has been initially pitched by the Geneva Airport, and I'm glad to welcome today Jose Rodriguez from Geneva Airport, who will be joined by EUROCONTROL expert Miroslav Špak. So the floor is yours.
Hi, good morning to all of you. As you already know, this project started from the observation that for many years now, delays on the network have been increasing year after year, and that's they are spreading throughout the day. This phenomenon generates a significant delta between the scheduled operation and what we observed in reality is more or less the same issue than we have been listening since now in the other projects. And this generates difficulties in terms of resource allocation for all our partners. To solve this issue, the idea is to understand and try to anticipate the evolution of the traffic as the day progresses, and then be able to predict delays sufficiently in advance to allow early decision making. The aim is to reduce the impact in terms of operational planning, but also in terms of system performance. This would reduce costs, but also improve the working conditions of those involved in the daily operations, which is really important also for us. And in terms of deployment, the idea is to be able to associate the predictions of delays for each flight of the day with different passengers flows in the different processors. And at the very end, this will give us a better view of aircraft, passenger, and baggage flows. The use of tools that integrate these elements within the APOC, the Airport Operations Center, is obviously our main objective. You can move on to the next slide. please. All right, thank you. In terms of scoping, when we defined the scope with the working group, we have identified three key elements that we need to address. The first one is the passenger demand. Then the second one is the in-block and the off-block prediction and time deviation from the actual or from the schedule time. Sorry, and yes, taken to the extreme, and with a system for monitoring the performance of the predictions. The calculated times would then replace the scheduled times provided by the airlines in our resource allocation system, but also in our future demand calculation balancing tools. I now give the floor to Miro for the rest of the presentation.
Thanks a lot, Josh. Hello, good morning, everyone. So this is just to give you a bit of an insight on the project duration. And so, because I know we have a lot of new players around this virtual table, just to give you a bit of insight on how demanding it might be to complete the project. Even though it's an agile approach that we all have in the project team that is composing of Geneva Airport, Rotterdam Airport, Swiss, ENAIRE, and recently we also had interest from vueling. The most important phase that we had was the scoping one. So it is very important that before you, once the idea is being approved for the innovation project, you have to be sure that you identify appropriately the scope of the project. So you have to look very carefully on what is existing, not to reinvent the wheel, and that you are focusing on the project deliverables. So basically what you're looking at here, that's the project roadmap for our deliverables, which is actually split into three mandatory deliverables, and the last one, the fourth one, is the optional one, which is expected to be reevaluated after the first three deliverables. So the most important is the project scoping phase. Then you have the methodology development, which we are currently undertaking. And then we have the third deliverable, which is the most important for us, which is the model development, the prototype development, which will be visualizing block time deviations and passenger demand predictions. Then we have the last deliverable, which is meant to be as a revision of a developed model and put into the operational trial at Geneva Airport. In total, the prototype is expected to be delivered within 5 months from the start date. And afterwards, we have additionally planned 4 months for the redevelopment of the model, if that is further needed and successfully advanced for the operational trial. The most important part is data gathering and preparation for the model. So when you're scoping your project, please be careful. Try to focus on the project objectives and how you want to address the objectives. That means what data you will need. Try to see what databases you will have to access, what data sources you need from these databases, what data elements from these databases you need, whether they're accessible, whether it's actually feasible to deliver the scope that you are intending to do. So data collection, data provision, data quality check, database preparation for the model feeding. That's the most important part of it. Please, next slide. At the moment, we are in the phase in the methodology development. So we have the scope ready. And now we said, we do not want to reinvent the wheel. Just linking up on what Paco said about a couple of models that we already have in our mirror tool, such as iDemand or Night Curfew. So those are already existing models that help predict the in-block and off-block time deviations in the tactical phase. What we want to do, we would like to move more into the pre-tactical phase. And the primary focus, as Josh said, is on the turnaround duration predictions, because that is going to dictate what will be the off-block predictability. So we're focusing in the terms of the block time deviations on the mirror tool using existing models within the model. We're also focusing on respective airline delay indicators that are also in place, and we can well use them for the project scope. And we are also having methodology developed by Geneva Airport, which is already addressing block time deviations. So as you see, we are really trying to see what can be used, what services are in place, what tools are already in operations, what methodologies are written in order to support the project deliverables for that particular project. On the passenger demand side, we already have also two feeds. The one comes from the prediction, which was developed by EURONOVA in collaboration with us, EUROCONTROL, which is providing the passenger demand predictions in terms of load factors and also counts per day and per hourly views. And we also have Geneva methodology and tools which are already in place, which already take some features into calculation to predict the passenger demand on the day of operations. Next slide, please. And as said, focusing on both block time deviations and passenger demand predictions, the ultimate goal is to create the prototype, which will be in a form of a dashboard where a user can have a look at both the passenger demand predictions and the block time deviations predictions as well. So this is only the result that we have from one of the already developed services for the passenger demand, where we are able already to predict based on different predictive features the evolution of the passenger demand between countries, between airports, etc. So this is the so far achieved result. And as I said, we're not that far as other projects within the cycle 2. We are in the methodology phase, really focusing on what we have, what data we have, what data we want to use, what data we need to have for the to reach the objectives. And the ultimate goal is to have that kind of prototype that is supporting airport optimization for the resource optimization. And last but not least, I would like to thank to the team, which is performing excellent, and the teamwork is just fantastic. Thank you.
Thanks a lot, Miroslav, and thanks a lot, Jose, for this presentation. I would like to thank as well Peter for the introduction that he's done for the event today, and as well all the presenters of the different cycle 1 and 2. So I'm taking the floor now. I'm Marta Llobet, and I'm going to be facilitating the next part of this event, addressing the cycle 3. So the cycle 3 that we are launching now today, this is, as Peter explained it at the beginning, we have been going through the first part of the process for this cycle 3. That means the connect part and all the ideation process. And there was a speech session organized several weeks ago in which different stakeholders provided their inputs and ideas. And after the selection process, there was a short list that has been retained for going through the full cycle of cycle 3, sorry. So you can see here we have 3 new projects. We are going to have the verification of military aircraft performance for GNSS approaches and aircraft operator take on available and released airspace, Cura barrier. So these are mainly related to military stakeholders. And we have a third one, which is airport ones, which is massive diversion. So we are going to start an overview, just of an overview of them. And we are going to start with the Wing Commander Peter Sones from the UK MOD, that he's going to explain us a little bit what this idea of verification of military aircraft performance from GNSS approaches is about. So Peter, please, and the floor is yours when you want.
Good morning. I'm Wing Commander Pete Soanes from the Royal Air Force, and I represent the Defence Airspace and Air Traffic Management here in Europe. Next slide, please. So what we're looking at here is how we use military specification GPS for flying GNSS approaches. Obviously, navigation systems derived from GNSS to meet the requirements set by EUROCONTROL and other regulators. We're used to seeing those and using those, but the military aircraft don't carry necessarily those equipment. Particularly our larger aircraft will, but our smaller aircraft suffer due to the extra weight required to carry non-military equipment, a lack of space potentially in the cockpit and avionics bays, but also we have to prioritize what the aircraft carry, whether that be operational equipment or something such as GNSS. So we already have military spec GPS navigation systems, and we need to look how we can operate those to fly GNSS approaches, but also there's an additional cost to adding in additional equipment. Now, the fact that our aircraft can't fly these type of approaches, it has an impact on us because it affects our freedom of maneuver. We can't use necessarily all the approach options at an airport, and we may have worse minima for those that are available. But also, if we can't use those airports, we may have to go to another location, which would increase our fuel burn. And it may even, in fact, in poor weather, increase unnecessary diversions. But also, it impacts ANSPs, and by impacting the ANSPs, other aircraft operators, because our platforms will become something of a burden, because it's harder to sequence aircraft that aren't flying the same type of profile, so you potentially increase separation. It will certainly increase controller workload, and therefore there could be knock-on delay to other platforms. Next slide, please. So working with our colleagues here at EUROCONTROL, where I actually sit within the CMC section here, we want to develop a process that will enable us to assess the ability of military GPS-equipped aircraft to fly GNSS approaches. So this will be a whole system approach. We have to look at not just the GPS performance itself, but how that fits in with the wider navigation system of that platform. So the task we have, we'll have to identify what data is required, gather that data, identify a method of assessment, and also develop ultimately a process or procedure that means the individual nations can provide assurance that their aircraft will fly these procedures safely. So we'll be looking at the whole navigation system performance, and we must meet the civil GNSS approach criteria. Potentially, we may look at investigating the recognition across multiple nations that operate the same aircraft type, just to ease the burden and reduce repetition of this. Next slide, please. The expected benefits, it's the flip side of the disadvantages. It should enhance safety because we can fly to lower procedure minima and therefore make approaches in worse weather conditions. It will reduce controller workload. It should simplify approach sequencing by having fewer types of approach to fit in. Reduced environmental impact due to reduced CO2. And it will provide flexibility for us as nations across the EUROCONTROL area to choose where we fly to, and even outside the EUROCONTROL area where we could potentially use this for expeditionary operations. It will enhance ATM capability, or capacity rather, simplifying sequencing, reducing controller workload, and potentially reducing knock-on delay caused by that additional workload. We appreciate that there is some synergy with other ongoing work within CESAR, looking at the wider use of GPS for navigation on the military and how we do performance equivalence, but we will be staying clear of that work to avoid repetition. But also at this time where we're looking at the UK as a non-EU country and civil military cooperation being something EUROCONTROL needs to look at, this is a great message if we can actually show that the UK is continuing to stay engaged and that EUROCONTROL is engaging with the UK in return. Next slide. In fact, that's it. Okay, thank you.
Thanks a lot, Peter. Thanks for having presenting this new project that mainly aims to improve ATM efficiency for all the airspace users at the end of the day. Thanks a lot. So let's move now to the next new project, still from military stakeholders. So it will be the Lieutenant Colonel Raymond Martin, who is Chief ATS Officer in the Defense Forces of Ireland, and he's going to present us the aircraft operator uptake on available and released airspace, so the CURA areas. So please, Raymond, the floor is yours for the presentation.
Thank you very much, Marta. And I suppose kind of the project that we're proposing is an assessment or a study into aircraft operator uptake on available and released airspace. Next slide, please. And the context in which we're looking at this is primarily the usage by aircraft operators of flexible use of airspace, or FUA, which really has been around since 1996. So actually this month is its 25th anniversary. And while it releases a lot of airspace and has pushed capacity into the system, it has been obvious for perhaps a decade or even more that not all aircraft operators are actually exploiting the opportunities by FUA. And I use the term aircraft operators advisedly because kind of I'm aware that not every airliner or airline might actually be the aircraft operator that's actually filing and flying the aircraft as such. And also I'm including civil and military aircraft operators in that, because it's certainly known to me that at least some military aircraft operators don't use the airspace that's produced or released through the FUA system. And also we need to consider the airspace that hasn't been booked by the military. So not necessarily just focusing on airspace that has been released, but also the airspace that hasn't been booked. So it's known that this airspace is available for a considerable period of time. And then also looking at the airspace that hasn't been released by the military. Next slide, please. And why would we consider this? Well, kind of effectively, if we look at the heat map or flight density through 2020, and this slide has been compiled by CMC inside Eurocontrol. You can see there the purple areas and the darker areas are effectively an indicator of the flight density. And from that point of view, we can see on the left-hand side, the weekend situation is very similar to the weekday situation. But of course, there's a difference between the two periods, because typically the military airspace is not activated over the weekends because we tend to train Monday to Friday typically. So from this point of view, this slide projects an idea of the potential problem that is there that we need to seek to solve. And we need to look at both the planning aspects and also the usage aspects as well. And obviously the question there as well, if airspace is largely available at weekends, why are the heat maps so similar? And next slide, please. So when looking at the study, kind of the objectives that we would see are, first of all, to identify the problems or the barriers that are there that prevent aircraft operators making maximum use of flexible use of airspace, and also to quantify the problems and the potential benefits. And then, of course, identify potential digital solutions. And I think kind of if we go on to the next slide, effectively to achieve these objectives to a degree, the expected deliverables, well, first of all, a qualitative study report and a qualitative study leading to that should identify the barriers to planning through or using the available airspace. And to a certain extent, I suppose, this is to really say, what are the reasons that prevent the uptake of FUA? And from this, we should probably get an idea of, one, what the customer, the aircraft operators, want from FUA, and that should allow us to increase the uptake of FUA as it is, and also into the future, inform any decisions towards FUA in the future. And finally, also, a final quantitative study report should identify the opportunities and potential benefits, and obviously will identify the cost and benefits in terms of the non-usage of airspace and the potential benefits that will result from the take-up. And probably more identified or informed by the qualitative study, digital solutions or solutions addressing the problems which have been identified. And of course, the qualitative aspect, again, providing the justification for that. So hopefully this will ensure that we will improve the usage of airspace and provide real benefits for all the users, both in terms of capacity of the network, but also reduced fuel burn and reduced emissions as well for all the aircraft operators. So thanks very much.
Thanks a lot, Raymond. So thanks for having presenting this other project. New one, yes, trying, as you said, to optimize the use of the airspace and mainly addressing the blocking points that currently have in order to try to find a solution for that. So thanks a lot, and let's move now to the third project, new ones of this cycle 3. In this case, we are addressing more airport-related issues in some ways. So it will be José Luis Nieto from AENA who will talk about massive diversion, this idea and this proposal for the project. So José Luis, when you want, please.
Thank you, Marta. So speaking about massive diversion, why massive diversions? Well, we have detected in a network as AENA of airports is that when we have capacity reduction at an airport, expected or unexpected, for example, in weather conditions, that can affect the capacity of an airport, and we have rate zero in some parts of the day. We have detected that arrival flights need to divert to their alternative airports. This may cause over deliveries to other airports, even smaller, and apron congestion, and in some cases, safety problems. We have to coordinate between different ATC units involved, the surroundings airports, crews, and also airlines. So it's a very complex process where airports provide availability, capacity, and airlines need to coordinate in their operative centers how to handle the situation and where to divert. This process is commonly performed manually and could surely profit from automation. So the objective to answer the question, what for massive diversion projects? To produce a tool to automatically assess the stand capacity available in an airport's network. Airlines can check ground capacity and decide where they can send their flights if alternate airports have no capacity anymore. And also ATC and Network Manager Operational Center can improve the common situation awareness to facilitate coordinations with crews and manage this kind of situation. And the challenges that we have, Marta, next, please.
Normally it's there.
Next, please.
I already moved the slide.
Oh, sorry.
Normally people see the challenge.
Okay. Yes. Airport capacity. The challenges that we have. Yes. Airport capacity repository to storage nominal instant availability and attributes, aircraft type or class, accepted dimensions, and maximum takeoff weight, for example. This can be a starting point, but nominal capacity is not always available due to incompatibilities or works in progress in airports. So there are other points to take into account. The translations of Icao aircraft types into traffic classes for stand allocations. Stands are classified for a group of aircraft types. Even same aircraft type with different configurations, for instance, with or without wing lengths, and this with this we may need different stands or incompatibilities. It's important to assess if current classification are enough for new functionalities. Aircraft capacity in real time, integration of real time stand allocation information by different means. For example, new B2B messages or uses for API and DPI, arrival apron stand information integration to build at need the occupation of the network, and also airport network capacity visualization. Accurate knowledge of vacant stands availability at a certain period or time. This could be presented on request upon a sudden or forecast adverse condition and for all airports within a given range. This means that when an event happens, expected or unexpected, but because issues happen in airports because weather conditions or drone flies in an airport area, or even volcanic ashes that we are suffering now in the Canary Island. They involve staff and trigger the composition of the ability stand capacity view for at least the declared alternate airports of the affected flight plans. So the stakeholders are of course airports, airlines, NSP, and network manager. And that's all from my part. Thank you, Marta.
Okay, thank you very much, Jose Luis. Thanks for having explained us these new projects in cycle 3 aiming to better manage and mitigate this massive diversion. As you know, the next step for the cycle 3 now will be the build part, and this will start in the following weeks, in the next 2 weeks. So there is here a call for interest for all the potential stakeholders that will be might be interested in joining the projects. You see here in this table a little bit the kind of stakeholders that might be needed. In bold is mainly the ones that is really a key participation of these kind of stakeholders to participate in the projects. The other, of course, ROC foreseen because they can provide additional benefit. So the idea is for the projects to expect participation from aircraft operators, both civil and military. We are looking as well for ANSPs to participate in the 3 projects. There is a need from airports as well, stakeholders, and for the computerized flight plan service providers. So this is the request. It's a call for interest. If you want to join or you want to have more information, please contact us. You can see here the mail address. Send us an email and just show your interest and explain. Okay, so with this, we finished the cycle 3 part of the event, and I'm going to pass now the floor to Laurent Renaud, who is going to conclude, give some insight of what is next for these innovation projects. Laurent, when you want.
Yes, good morning, everybody. I just need to switch on my video. Sorry, I don't have the button. Start video.
On the top, maybe?
Yeah, it should come. Okay. So good morning, everybody, and thanks for joining us. First, I would like to echo the team and thanks all the panelists. We could see very promising results from the 2 trials ongoing. We could have a flavor of the development of the 3 solutions out of the 8 operational challenges from cycle 2. And I'm very pleased that we launched the cycle 3 where our military colleagues are now part of our initiatives. So the scoping phase of the 3 projects now will start. But now let's project ourselves to the coming months and see what's going on in January and after. So the ideation for cycle 4 will start in January with up to 4 pitch sessions from February to March, with the goal to select the next batch of operational challenges early April and have our promote event on April. So if you move to the next slide, let's detail this promote event. We will be very pleased to receive you here in our Innovation Hub in Bretigny on April the 12th. The goal is on one side to demonstrate what was achieved so far from the first 3 cycles and to kick off the cycle 4. Of course, this will be an exciting opportunity to network each other. And so you will be invited the evening before on April 11 for a networking moment. And that will be also an opportunity already to showcase the solutions being developed so far. And we'll continue on April 12 in order to share the result for the first 3 cycles and launch the cycle 4. So we are really looking forward to seeing you each other in April. And so please save the date, April 11, April 13. And again, thanks a lot for all your participation, for listening to us, and thanks again to the team and for the panelists. And we wish you a very good day and keep inform each other. Thank you.
Bye-bye.